Good evening students. Today we are going to discuss about a new chapter, that is structure of atom, and its unit is 2. As you know that an atom is made up of electrons, protons and neutrons. For that we need to know the electronic charge, which means that the charge of an electron. So the charge of an electron is 1.6022 into 10 to the power minus 19 coulomb. So this is the charge, and the mass of an electron is 9.1 into 10 to the power minus 31 kg. So this thing you have to remember, it is 1.6 into 10 to the power minus 19 coulomb, and the mass is 9.1 into 10 to the power minus 31 kg. So directly they might not ask you what is the charge or what is the mass of an electron, but for doing the numericals you need to know these informations. There is another important information, that the number of protons in the nucleus of an atom is equal to the number of electrons in a neutral atom. So the number of protons and electrons are same. So atomic number, when we say atomic number of an element or an atom, we mean to say the number of electrons. The number of electrons directly represent the atomic number. But when we talk about mass number, it is the number of protons and number of neutrons, or number of electrons plus number of neutrons, because you know in place of proton you can write electrons because the numbers are same here. So mass number is the addition or the total number of protons and neutrons taken together. Another part which is being excluded from your portion is the isotope and the isobar. Just for information, you remember that isobars are the atoms. Okay, there can be two different atoms with same mass number but different atomic number. For example, carbon and nitrogen. In this carbon atom, you can see that the mass number is 14. Usually the mass number of carbon is taken as 12, but we can also see isotopes of the elements, and now we will study what is the meaning of isotope. In that case, the carbon has mass number 14 and atomic number 6. Nitrogen has mass number 14 and atomic number 7. So these two atoms have similar mass number but different atomic numbers. Hence these two atoms are known as the isobar. And the opposite is for isotope. Isotopes have same atomic number but different mass number. In isobar, same mass number but different atomic number. In isotope, it is same atomic number but different mass number. And we used to represent the atomic and mass number as follows, like 14 is written in the superscript, and 6, which is written at the bottom, is like the subscript, that is written 6. Okay, so this is how you represent the mass number and atomic number of an element, and these are the isotopes and isobars. Now we will move on to another topic, which is the electromagnetic waves or electromagnetic radiation. Now, as you can see that electromagnetic, the name is suggesting something related to electricity and something related to magnetic bars, right? So it is nothing like any means different from this, the name that is suggesting. It is electromagnetic, means where electrical and magnetic properties are involved. Now when there is a situation that we can observe the electromagnetic waves or electromagnetic radiation, there should be some situation under which both these properties come into being, right? So what is it? It is written very clearly here that when electrically charged particle, when a charged particle is moving means it is in motion. When a charged particle is in motion, then alternating electrical and magnetic fields are produced. So this is how electromagnetic radiation is produced. Okay, and magnetic fields are produced and transmitted. These fields are transmitted in the forms of waves called electromagnetic waves or electromagnetic radiation. Now for clear understanding, we have to see the properties of these radiations. Let us see what are these. Here again, one important thing you have to remember, that the first scientist who did the experiment on this electromagnetic radiation or waves is who? It is James Maxwell. So this name you have to remember, and now you are going to see some properties of this electromagnetic radiation. So you can see that the oscillating electric and magnetic fields produced by oscillating charged particles. Here oscillating means you can say in motion, okay? In the moving charged particles are perpendicular to each other, and both are perpendicular to the direction of propagation of the wave. Now you know that you know Cartesian coordinate, right? In Cartesian coordinate there were three coordinates, x, y and z. You just imagine that, okay? There are three planes. The x will be, suppose you consider the x will be like this, right? Y perpendicular to x, and another one will be like this. So it is this way. This is z, this is x, and this is y. All three are perpendicular to each other. Now you have to imagine that the line of propagation is this. The charged particle is moving in this direction, okay? Then the electric field, suppose you say the charged particle is moving along this book, okay? Then the electric field will be like this. Clear? It will be perpendicular. And the magnetic field will be in this way. Clear? In this way also it is 90 degree. No, you can see if it is moving in this way, then from the top also it is 90 degree, and from the side if you imagine, then also it is 90 degree. So all these three directions are perpendicular to each other, and that is given in here. You have to say that the electric field component, the magnetic field component, and the direction of propagation or the direction of motion of the charged particles are perpendicular to each other. So this thing is important here. Unlike sound waves or water waves, electromagnetic waves do not require medium and can move in vacuum. So you know that in the space we cannot talk to each other because the sound needs medium to propagate. In order to reach this means the sound or the voice from one person to another person, we need air as a medium. Then only it will move from here from one person to another person. But the electromagnetic waves do not require any medium. In vacuum also they can propagate. Some other properties that define the electromagnetic waves are like frequency, wavelength, wave number, that you have already studied maybe in class 10. But now here we are again going to study these things. Like when we say frequency, what is it? It is the number of waves. Like here in this diagram you can say this is one wave, right? So it is the number of waves that pass a given point in 1 second. Means in 1 second how much or how many number of waves is moving. If you consider one point, suppose you consider this point here, from this point how many number of waves are moving, how many number of waves are passing this point in 1 second, that is the frequency. Okay, it means like you are going to market in a day you are going 3 times, so that is the frequency, right? That is the number of times you are visiting the market in a day, per day. Here the same thing, the number of times the waves are passing at one point through one point in 1 second. Here it is not in one day, it will be in 1 second, so that is frequency. Okay, number of times.